Hello everyone. Today in this video we are going to discuss about nilpotent matrix. It is also a square matrix, and for this case you will get one specific criteria, that is a to the power m. A to the power m is equals to null matrix. A to the power m equals to null matrix. What is m? M is the least positive integer. Okay, least positive integer, and this m sometime it's called index of the matrix A. How question will come from nilpotent matrix? See, we have learned idempotent matrix A square equals to A. We have learned involutory matrix, that is A square equals to identity matrix. Now nilpotent matrix is quite different. Here not A square, here A to the power m equals to null matrix. What is m? M is the index of matrix and m is least positive integer. Now question will come again the same way. One matrix will be given to you and they'll ask, this is idempotent, involutory or nilpotent matrix. Again we have learned one short way to identify. You can multiply it a into a, how many times, 3 times, 4 times, that depends. But if we are looking a short approach, we are looking for short approach, so how we'll do it? So suppose this is a matrix, so we have to find out non-zero elements. So this is non-zero elements, this is also non-zero elements, so we have to write the place of non-zero elements. So 1 represent in the place of 1 comma 2, first row, second column, yes or no? And the second one non-zero element is 2 comma 3, second row, third column. Are you getting my points? But now see, we are looking for multiplication. Now this is a, this is a, so if we look for a square, so if we look for a square, this is a value, this is matrix A. So if we look for a square, that means we have to multiply again by the same elements. So we are looking for a square first of all. So I am looking for this, again we'll multiply it. A square means we have to multiply again by the same elements, 1 comma 2 and one more is 2 comma 3. Now we have to find out row and column place is similar. So where it is, we have to find out. See, this is row places and this is column places. That means from these two sector we can obtain 1 comma 3. That means first row, third column, one element will come. I don't know which elements will come, but they will come. But we can identify also, this is 1, this is 2, 2 will come, definitely 2 will come, but this is non-zero element, so this is coming. Now if we look for these two also, see, the same is coming, why? See, this is column is 2, this is row is 2, so ultimate which element? 1 comma 3. That means this is coming as a result for a square. Now a square is not a null matrix, that means we cannot say it is an involutory matrix, but we can proceed for the next step. So we'll increase one more step. So now we are looking for a cube. So if we want to look for a cube, that means with a square we have to multiply a. Are you getting my point? That means a square we have already this place 1 comma 3. So now we have to multiply this by 1 and 2, and another one we have to multiply with 2 comma 3, because this is a elements, 1 2 2 3, this is a element. Now see, with this is it possible to multiply? See, is there anything common, row and column, because this is also column space, this is also column space, okay? But see, now we cannot multiply, it is row place, it is also row place. So with 1 comma 3 it's not possible to multiply, with 1 comma 3 not possible to multiply. That means we are not getting any kind of elements, so ultimate we are getting result as 0. So for this reason, this is a nilpotent matrix index 3. That means a to the power 3 will become 0. Are you getting my point? How I am getting the solution? This nilpotent matrix index is 3. Now see this one, you solve this one and try to get it how it is. See, from here we can identify one more thing. You know what is that? That is characteristics equation. You know characteristics equation is very simple. Just what is the order of this matrix? It's the order of this matrix is 3 cross 3. So we can write here characteristics polynomial and minimal polynomial also. So we can write here characteristics polynomial of this matrix. What is characteristics polynomial? The form is x to the power. This is a variable because polynomial we are writing by x to the power. See, x to the power. What will write for both case? X will come polynomial since it is a polynomial. So x to the power here will come for characteristics equation x to the power order. X to the power order order of what is the order of this matrix? Order of this matrix is 3, so answer will become x to the power 3 for this case. So and for minimal polynomial, x to the power index, what I said, index and order is different. Here index x to the power. So what will be the result for minimal polynomial? For this question both are x to the power 3 because index also 3, order also 3. Are you getting my point? But if you look for the another question, another example, if you look for this examples, is very easy to identify the non-zero element present only in a single place, that is 1 comma 3. Are you getting my point? Now if you want to find out a square, so we have to multiply 1 comma 3 only. So 1 comma 3, if we multiply with this, is it possible to multiply? I think you got, no, it is not possible, sir. It is not possible because see, we need same number in row place and column space. But see here, 3 and 3 present, but they are in same places, column only. We need one row, one column. That means here we are getting result in a square only. First case only we are getting null matrix. Got the points? But for this case, what will be the characteristics polynomial and what will be the minimal polynomial? What will be the minimal polynomial? What will be the characteristic polynomial and minimal polynomial? I think you can identify the characteristics polynomial means we have to find out the order of this matrix. Sir, the order of this matrix is 3 cross 3. Exactly correct. So answer will be x to the power 3, sir. Correct. What will be the minimal polynomial, sir? Here minimal polynomial means we have to look for index. What is the index for this matrix, sir? 2. So for this case our minimal polynomial will be x square. Are you getting my point? Why I have taken these two examples? From these two examples you can identify characteristics polynomial, minimal polynomial, and how to get immediate result for nilpotent matrix. Because for idempotent matrix and involutory matrix we know we have to multiply a into a, but for nilpotent matrix we don't know how many times we have to multiply, 3 times, 4 times, 2 times. So it's very short way we can find out index also and order also of the nilpotent matrix. So you have to learn to attend the question from nilpotent matrix. Next question will get as MCQ. Next question is given here. A and B are nilpotent matrix. Same question we have learned in idempotent, involutory, and nilpotent also learned. A, B both are nilpotent matrix. Then AB will be nilpotent matrix only the condition of commutative property AB equals to BA. We have learned in all the sector. But what will be the eigenvalue? See, we have learned eigenvalue for idempotent matrix. We have learned eigenvalue for involutory matrix. Now we have to learn eigenvalue for nilpotent matrix. Eigenvalue for nilpotent matrix, we know nilpotent matrix is equals to null matrix. So what will be the eigenvalue? Very good, it's very simple. Eigenvalue will be 0. So what will be the determinant value of this matrix? Determinant value also will become equals to 0 because we know determinant value of any matrix is the product of eigenvalues. Yes or no? Now in next question they are asking, if A is nilpotent matrix of index 6, very important question, index 6, then what will be the index of A to the power 4? A to the power 4. See, we have a two different way to obtain the result. See, A to the power 4 we have to multiply. How many times we will multiply? It will cross 6 because already it is given A is a nilpotent matrix of index 6. That means from here we can write that A to the power 6 already it is given a null matrix. It is given. it is given, but we have to find out for a to the power 4. We have to find out for a to the power 4. That means we have to look a to the power 4 how many time we have to multiply. For that it will cross a to the power 6. A to the power 4 how many time we have to multiply. Definitely you can identify, sir, a to the power 4 you multiply 2 times, it will cross 6. Definitely it is coming, see, a to the power 8. That means it is crossing 6, and a to the power 6 means 0. So ultimately it is also will become 0. That means from here easily we can identify a to the power 4. The index of a to the power 4 will become 2. Are you getting my point how it is? Or easily you can find out the any other way the result, that is greatest power integer. I think you know greatest integer function. So first we have to write the given index. Given index is 6, and which one you are looking for 4, index as 4. So we have to take greatest value of 6 by 4. 6 by 4 if we try to find out the greatest value, this is another method, or method. Okay, this is another method. 6 by 4 means 1.5. 1.5 means, you know, as greatest integer we will get 2 only. So this way also you can find out a result. Okay, another one, it is given what is the index of this matrix 57006. This is given. What is the index of this matrix? Now again, if you look for this, if you go for multiplication you can go, but I will not go for multiplication. I will do in the very short way. What is the short way? We have to find out non-zero element, that is one. This is 1 comma 2. This is 1 comma 2. We'll write it 1 comma 2 here. 1 comma 2 places. Another non-zero element is 1 comma 3 place. Okay, another non-zero element present is 2 comma 3 places. Now we are looking for a square, so we have to multiply by the same, because we are looking for first a square, then we'll go for a cube, then we'll go for a to the power 4. 2 comma 3 non-zero element we are writing. Now which places, that means which element will take, for that they can make one relation, which element is there. So we are looking for only one. I am getting, see, because this is column space, this is row space. Okay, now that means these two we can take, these two elements we can take. So what will come? 1 comma 3 will come. See, other than this you can make here also, you can make here also. Where it is, you can make here also. See, these two, other than these two you cannot make, because here also 2 row space and here column is 2. So ultimate answer is coming 1 and 3. So this is the value of a square, because a into a I have multiplied, but it is not null. Again we have to multiply a square into a. So we are looking for a cube. A cube, that means a square already I have, that is 1 comma 3. And what is the value of a? Value of a is 1 comma 3, not value, just in the short way I am telling. 1 comma 2, 1 comma 3, and another one is 2 comma 3. Is it possible to multiply this element with this, just to check? No, it's not possible. You check nicely, it's not possible. You cannot multiply with this, you cannot multiply with this, you cannot multiply with this. That means ultimate it will come null matrix. So what is coming? A to the power 3 equals to null. From here easily you can identify, say, index of this matrix will be 3. Are you getting my point? What I said, index of this matrix is 3. So like this kind of question will come in your examination from this sector. So in this video we have learned till this much only. Thank you so much.